everybody. Thank you for joining me for today's World of Weather. It is Wednesday, isn't it? It's Wednesday. It's so hard when you're working from home. I feel like we're twice as busy. You almost forget what day it is. Maybe you're doing the same. It is Wednesday, halfway through the work week, and we are doing today's World of Weather. Look, I have my globe that we use for so many lessons, and we're talking about sunsets today. A little bit about sunsets, what they are. We're going to talk about the colors associated with sunsets and the colors of the sun, because if you notice, when it's up and it's noontime and you look up at the sky, for example, if you looked up at the sun right now, not with your bare eyes, but in general, the sun appears white. So how come when the sun is setting, does it sometimes appear yellow and orange and red? Have you ever wondered that? So we're going to talk about why that happens. First, we are going to do a little refresher so we can understand the sunrise and the sunset, and it all has to do with the Earth. So this is the Earth that we all live on. There is the United States. Again, we're in the northern hemisphere. There is Georgia. Hi, Georgia. There you are on the map. So a quick refresher. The Earth is slightly tilted and it spins, right? So it spins and it does one full rotation every single day. It takes 24 hours for the Earth to do one full rotation. And that is why there are 24 hours in a day. Now, I'm going to bring over this light, because this light here, this is what we call a ring light. This is what gives us light. This is going to be my light. So pretend the light, which is over here, we'll even turn it so you can see it. It's bright. That is the sun, right? So we have the globe here. And as the globe spins, you can see the sun right now. See, it's hitting Africa, it's hitting Australia. So as the Earth spins, the areas that are facing the sun are who are getting sunlight. And then those areas on the back of the globe, they're nighttime. See how dark it is on this side compared to this side that's facing the sun? So 24 hours a day, that's why the Earth spins. Takes 24 hours, which is one day for an Earth to do a full rotation. Something else that you will notice is that the Earth spins towards the east. So it is moving from west to east. So the Earth is spinning in this direction, from west to east. Because of that, you'll notice the sun, the moon, the planet, the stars, everything you see up in the sky. As this is spinning from west to east, you'll notice it rises in the east. You'll notice it comes up from the east. Then it goes up across the sky and it sets in the west. So you'll notice everything rises in the east, sets in the west, and that's just because the Earth is spinning from west to east. So can everyone remember that? Rises in the east, the sun rises in the east. So if you have a compass and you look at east, you'll see that's where the sun rises. At noontime, the sun is directly above us, and then it sets in the west. And it is, again, because of the spin of the Earth spinning from west to east. That is why that happens. So that is a little bit about the sun, why it starts in one direction, why it ends in the other direction. It is because of the sun. But another thing you'll notice is the color of the sun. It is white when it's up at noontime, and when it sets, it's reddish, orange, and yellow. Why does that happen? So we are going to explain that. For that, we're going to flip this camera around. As always, I have you right here on Facebook. If you have any questions, let me know. And I'm looking right now. Hi, Susan. Hi from Growing Minds Christian Academy. Hi, guys from Growing Minds Christian Academy. Thanks for watching. Let's see. Wesley, you're in Ackworth. Hey, Wesley, you're always watching. Thanks for watching. Let's see. Paul is always watching. And Latasha, you're watching from Houston, Texas, or Houston, Georgia. If you're in Houston, you're far away. Thanks for watching. I'm so glad you're interested in these weather segments. If you do have any questions, please ask them as we go along. So let's start today's World of Weather lesson. Again, we're talking about sunsets and the colors of the sun and why they appear certain colors. I'm going to move this light away a little bit so that it doesn't hurt your eyes when I flip this around. So World of Weather, sunsets, and maybe you guys already know the answer to why the sun looks different colors as it's setting. If you do, go ahead and let me know. So here we go, and if not, you're about to learn. First of all, again, we talked about the sunset in Atlanta. When it's up in the sky, the sun appears white, but as the sun is setting, it looks yellow, red, and orange. It could be red, it could be yellow, orange, or a mixture. Have you ever wondered why the sun appears to change color when the sun is setting. And that's what today's lesson is about. So this is why when it's midday or noon, the sun is directly above us. So the sun is much closer. The light from the sun travels a short distance. Now, you know about rainbows, and we talk about Roy G. Biv is what I say, but it's red, orange, yellow, green, blue, indigo, violet. So all of those colors, red, orange, yellow, green, blue, indigo, violet, all of those come together to make light. So light is made up of a bunch of spectrum of colors. When all of them are together, the light appears white. So when the sun is directly above us, it is closer to our eyes, closer to us on Earth. So we see all of those colors. We see all of them. And when all of those colors are together, the light appears white. Now, the further the sun gets from us, we start to see scattering. It's called Rayleigh scattering, that these little particles here of light start to scatter through the atmosphere. They can scatter through clouds, through dust particles, pieces of ice, pieces of water, but we lose some of those particles. So as the sun is setting, it's actually much further from our eyes. So a bunch of those particles start to scatter, and the one that stays is the red light. So we see that red. So let me show you in this graphic this to understand. So again, light travels a short distance when it's above us, so the sun appears white. At sunset, keep this in mind, the sun is further away from us. So the light has to travel a further distance. So it's like shining a flashlight through a toilet paper tube, or shining a light through a big tube that was used for wrapping paper. The wrapping paper tube is much longer. The light has to travel a longer distance, whereas the toilet paper tube is much smaller. So it's a similar concept. When the sun is setting, the light travels a greater distance. So this is what it means for us. As the sun is setting, and again, there's the moon, the sunset, the sunlight has further to travel to reach your eye as it nears the horizon. And again, that's what we just talked about. We talked about the sun has all those colors in the rainbow: red, orange, yellow, green, blue, indigo, violet. And it's all made of visible light. Now, blue and violet, which is at the end of that, they have short wavelengths. The red has the longer wavelength. Those colors that have shorter wavelengths are more likely to scatter with particles in the earth. So again, dust, little microscopic water molecules, water vapor, clouds. Those short wavelengths scatter much easier than the bigger wavelengths. So here's the sun way over here. Here's you right over here. And it has a long distance to go. So they're traveling, and then you have these little dust particles, and they start to scatter all over the place. So as everything starts to scatter, the one with the longer wavelength, that is the one that finally reaches your eyes. So it appears red. So again, as the distance increases, most of the light left unscattered is red and orange. And those red, orange, yellow, those are the colors of light with the longest wavelengths. And that is why they appear red, yellow, and orange. And as you look at it, red, that's why it goes in order: red, orange, yellow, green, blue, indigo, violet. That goes from the longest wavelength to the shortest wavelength. So we see those longest wavelengths a lot easier. So because the sun is traveling the light through a longer distance, the red, which is the longest wavelength, that's what actually makes it into our eyes. So again, the sun appears white when it's up above us at noon because it's traveling a short distance. The light from the sun is traveling a short distance. But as the sun sets, the sunlight is traveling a much longer distance. All the other weaker wavelengths, the shorter wavelengths, they scatter. The violet, the indigo, the blue, those are the first to scatter because those are the shortest wavelengths. So then only the biggest wavelengths actually make their way to reach our eyes, and that's red, orange, and yellow. So here's a beautiful picture of an Atlanta sunrise. And maybe you've heard that saying, the red sky at night, sailor's delight. Usually when you have that red sky at night, you have beautiful weather. But if you have the red sky in the morning, they say, sailor, take warning. Usually that means that we are going to have thunderstorms. So that's something we watch for here. And that's a question for the tornado, but I do have a trivia question for you. What color of light, again, it's red, orange, yellow, green, blue, indigo, violet. I have to say Roy G. Biv. That's why I learned it in school. Which color of light has the longest wavelength? Do you know the answer? Which color has the longest wavelength? And it's red. It goes in order. Roy G. Biv, the color of the rainbow, goes in order from longest wavelength to shortest wavelength. And really, all the colors you can see with your eyes, but as you start getting into blue, indigo, violet, those are harder and harder to see, which is why those are the first to scatter. And that is why the sun sets red. So next time the sun sets red, when you're looking at the sunset and it appears that color, you can tell your mom and dad why that is. So it's really interesting. And light scattering has to do with a lot of things. That's why the sky appears blue. That's why clouds appear white. It has to do with scattering of light. If you have a prism, a glass prism, and you shine light through a glass prism, you'll see it makes a rainbow where you see all of the colors. Another experiment you can do, and I wish I had a glass of water with me. We did this in one of the earlier experiments. You can make your own rainbow at home. Get a glass of water, get a flashlight, and shine the water, and then get a piece of paper behind the glass. Shine the flashlight into the glass of water, and the water will reflect all the particles that we just talked about, the light particles. And then on the piece of paper, you might have to move the paper a little bit with the light shining through the water, and you'll actually see a rainbow. You'll see all the colors of the rainbow: red, orange, yellow, green, blue, indigo, violet. So that is similar to what happens with the sun. The only thing is the sun is further, so you start to lose all of those light, the visible light through the particles, and what ends up seeing is red. Kind of complicated, but hopefully I help you understand and it makes sense. And at the very least, hopefully now you understand why the sun rises in the east and sets in the west. So, and it's again because the earth is spinning, and that's around all of the globe that happens because the earth is spinning in the same direction for all of us, regardless of what country or where you are on the planet. So I'm seeing if we have any more questions. Joseph, when do we get more rain? Joseph, we get more rain on Friday. So actually 20% chance of rain this afternoon, mainly in the North Georgia mountains. We'll see some clouds increase, couple little sprinkles, but really Friday is our next chance of rain. Today's rain will be really isolated. Red, you got it. So I think that's it. Dennis is watching. Hi, Dennis. So everyone, thank you so much for watching for today's World of Weather. Hopefully you're learning a lot about weather, the atmosphere, the planets, the sky. That's my goal, to teach you all kinds of fun stuff. And it's stuff you can use every day, stuff you can understand, and that really is going to impact you every day because it's stuff every day we see a sunset or a sunrise. Every day the earth is spinning from west to east. Every day the sun rises from the east and sets in the west. So these are things that you can always carry with you. So tomorrow's lesson, we are learning about clouds. Maybe we'll go outside to learn about clouds. And then we're learning about weather on Mars. So we have a lot of stuff to learn about. We're also going to talk about El Nino and La Nina, which was a lesson we had previously planned, but we had some severe weather, so we had to skip past it. So we'll go back to that as well. Everyone, thank you so much. Have a fabulous day. I will see you tomorrow at same time, 1:15 for World of Weather. Everyone stay safe, stay healthy, enjoy this beautiful weather. A little windy out there. And again, we talked about winds and what causes the winds. So today's a perfect example. If you missed that lesson and you want to understand why it's so windy outside, go back on our CBS 46 streaming app, or you can go on our Facebook page, or probably easiest the website or the streaming app, and watch winds, why it's windy, and it will help understand why it is windy today. Everyone have a great day. I'll see you at 4 o'clock for the weather, and then I'll see you tomorrow at 1:15 for the World of Weather. Everyone have a great day.